Very warm good morning to everyone. It's a pleasure addressing you all. So, yeah, coming back to the discussions for today, the introduction is going to be something like this. Basically, I'll just give a brief introduction about our company, TMS Systems, what we are actually into, especially from the healthcare scenario. And then we will quickly talk about some of the basics pertaining to the biomedical instrumentation for us to move forward, especially when we talk about the medical devices, the design aspects, and subsequently we're going to talk about the product development process, and we can take a case study of one or two devices, and then we can also conclude by understanding some of the terminologies and the methodologies involved in the regulatory process for the medical devices. So this is how the presentation has been planned. So moving forward, am I audible, sir? Is it clear now?
Yes, sir.
Yeah. Kindly let me know in case if there is any pause or any disturbance. So because I wouldn't know.
Sure.
Sure. Thank you. So moving forward, about TMI Systems, we are basically a 25-year-old organization. We are headquartered at Bangalore. We have branch offices in different locations across India. Our main branch offices in Chennai, and our support offices are there in Coimbatore, Mumbai, Kolkata, and other places across India. So we basically specialize in biomedical instrumentation domain by offering product, solutions, services, and training. Our clientele, if you look at it, basically we have two or three parts. One is the technical institutions, where we cover all the academic institutions, engineering colleges that offer biomedical, medical electronics instrumentation, and other related disciplines by offering certain lab solutions. Then we also tie up with corporate sector and defense establishments by trying to offer certain specific requirements for their laboratories. And also we offer certain products, especially as a customized offering. So certain products are not readily available off the shelf. So in such cases, the end user requests whether it is possible for us to do certain customization specifically for them. So we do take up such customization work and try to offer the solutions either as a product or as a complete solution. And then we also work with defense establishments, especially where the impetus is now on indigenization of all the technologies. Especially over the last 3 to 4 years, we've been seeing the serious address from the government as well as all the private stakeholders trying to indigenize all the technologies, if not everything, at least to some extent, those technologies which are definitely possible from the Indian perspective. So we have been always importing, looking at the West or the Far East for certain technologies, and we all know especially our dependence on certain raw materials and the resources which are coming primarily from China and other countries. So when we talk about certain medical devices or certain test and measurement electronic products for defense and other establishments, now government of India has come out with very clear guidelines wherever it is possible, where it is possible for us to reinvent ourselves by indigenizing certain technologies, which can be a small kind of a push towards bringing a better ecosystem as far as the manufacturing process is concerned. So, considering this, a lot of industry tie-ups are happening, especially with governmental organizations, because without the private parties and other stakeholders, this venture will not be successful. So there is a lot of opportunities, especially for small enterprises, even medium enterprises, I would put it this way, MSME companies, where there are a lot of guidelines provided by the government of India, where we can collaborate with governmental organizations, defense establishments, provided we have the technical expertise. So, in that kind of initiative, we are working with a major industry, which is Hindustan Aeronautics Limited, and through our associates, we have been able to successfully envisage quite a few products, especially for the helicopter division. So under HAL, there are so many divisions. So we initially started with the helicopter division, and the project is going very successfully. And we have been able to convert a lot of ideas into prototypes, and which subsequently found a way for it to become a product on its own. And then presently, all the Indian Air Force and other departments, they are using this indigenized products. So that is a new initiative. And apart from that, we are also technical partners for GE Healthcare, where we provide certain basics training for students and other fraternities, especially considering from the academic point of view. And we also are kind of technology partners for Department of Science and Technology. We are industry partners for NHHID, which is a body of Department of Science and Technology, Government of India supported National Hub for Healthcare Instrumentation Development. So under this technology development and transfer, we collaborated with them. We acquired a couple of technologies, and we've been successful in converting one of the ideas into a product which has been commercialized. So that was with collaboration with Christian Medical College for a data recording system, which was a 8-channel physiological data recording system. And we are also working with Anna University on another image processing project, which is basically a software tool to work with the fundus cameras. We call it a mass screening device for ophthalmic lesions. So with this software, we are able to analyze the fundus image and to detect whether there is a diabetic retinopathy or glaucoma condition present. So this is another initiative that over the last 4 to 5 years that we have started to work with premier institutions, institutions of eminence, and other leading engineering colleges, especially where it is practically possible for us to collaborate, trying to acquire one or two technologies and trying to come up with a commercial model. So this is just a brief as far as our offerings are concerned as TMI systems. And coming back to today's talk, we are just going to start with some of the basics which are kind of a prerequisite for us to move forward, especially into the medical device development. So I wouldn't want to go into the very basics, but just to brush up. So we are aware of how diverse or how important our biomedical field is all about, which is basically, you have to take the best out of the engineering principles and techniques and you apply it into the medical field. We know that this field is multidisciplinary. We need to, use this design and problem solving skills and then try to, relate with the medical or the biological sciences with the idea or the objective of trying to improve the quality of healthcare, address the diagnosis and monitoring and therapeutic procedures. So, especially with this kind of very unfortunate pandemic of COVID, people have started to realize how difficult or how complex this kind of pandemic brings to the society. And it's a huge challenge, especially for the medical fraternity and all the other stakeholders trying to, come out with a vaccine or medicine, so whatever it may be, especially to immediately address this major crisis. So more and more inventions, discoveries, there is room for a lot of innovations, everything is happening around the globe. And especially for people who are working or connected with the healthcare, have found a way to, capitalize this opportunity and trying to, develop certain new models, new devices which can be catered to a particular situation. Especially, for example, now with this COVID, a lot of companies have come out with a lot of different ideas to address in their own ways. And also the other aspect that we need to understand is the healthcare delivery system, this delivery model, considering the population, especially from India's point of view. It's a huge group of population, and if you categorize them, you have a huge portion of percentage of people who are senior citizens, elders, and then you have the other middle-aged group, and then you have to have a clear picture of what is the proportion at which the medical centers or the facilities are available in India, and how this kind of a bridge can be narrowed down. So a lot of things have been taken up by the government of India and other private stakeholders in trying to bring in. So we now see this, especially this biomedical field has really, has come into the limelight, especially, and this is something possible because of the, the unique combination of skills that a biomedical engineer possesses, and how, as a biomedical engineer, we are able to, work with the healthcare industry apart from the biomedical engineers by working with a set of specialized individuals with different skills and trying to, have a synergy and how we are able to, move forward. So that is the beauty of this biomedical field all about. A simple example of how engineering principle used in medical field, we all know. It may look simple, but then, this is something like, this is being used for so many years, and still even till today, the doctors continue to use this in spite of, having a lot of digital BP meters and things like that. The simple device, but then very effective to have an indirect method of blood pressure measurement, especially to determine your BP levels. So moving forward, let us quickly understand certain basics of the medical instrumentation domain. We know that it is a subdivision of biomedical engineering, where we talk about all the measurement of various physiological variables from the body, which we eventually use for diagnosis, and also which can be used to perform therapeutic applications. So we know that it is a cross-disciplinary area. So the importance, especially from the engineering perspective, as a engineer, we need to understand certain things like the various mechanisms or the efficiencies, especially with respect to the physiological changes that are happening within the body. There are various subsystems within the body, and then the idea is to how to evolve an instrumentation system that can be used for diagnosis, which can be used for therapeutic and other applications, and also to supplement the body function. So we need to obtain certain qualitative and qualitative data with by handling various equipments that could be required for analysis. So the primary objectives of the biomedical instrumentation, when you look at it, the most important is the information gathering. When we talk about information gathering, we primarily talk about the instruments that are used to measure the natural phenomena, basically to aid the humans, especially in the quest of knowledge. So the information gathering is the most important objective. Then we talk about diagnosis. Diagnosis is primarily, we are referring to the measurements that are made. The measurements pertaining to detecting any abnormalities, any malfunctioning within the system, and how are you going to correct this. So the diagnosis is the most important aspect. Then the third part would be the evaluation. Evaluation is basically used to determine the ability of a system to meet its, we can say, functional requirements. And then you have the monitoring. The monitoring, what do we do basically is to monitor certain situation for a continuous or it could be a periodic information basically. And then control here, this is basically I would say we are talking about it is used to control the operation of the system based on certain changes in its internal parameters. So this kind of sums up certain objectives. What is the primary objective of this biomedical instrumentation area? So one has to have a fair understanding of the human anatomy and physiology as far as the functioning of the various subsystems, and this becomes very vital, especially because we are talking about designing and developing various medical devices. So it makes even more important for us to have a good idea of all this human anatomy and physiological systems. So when we talk about human anatomy and physiology, it's not only the gross anatomy or the topographical anatomy, it can be even the histology or the microscopic anatomy, and even the physiology aspects, especially the cell physiology or pathophysiology or circulatory, respiratory. You may have all these subdivisions, various subdivisions, we can say. And then most importantly, the physiological systems of the body, especially the cardiovascular, respiratory, nervous system, musculoskeletal system, digestive system, endocrine, you name it, you need to have a fair understanding of all these things. And especially when we talk about the cardiovascular system or the respiratory nervous system, these are some of the most basic prerequisites, I can put it that way, as far as going in deep into all these medical devices. So coming back to this basics of the instrumentation system, we need to understand about this basics, the block diagram, when you look at it as the man instrumentation system. This is the overall system which includes the human body and the instrumentation that is required for its measurement. So that is why we call it man instrumentation system. So here we are talking about the set of instruments and the equipments that are utilized in the measurement of multiple characteristics and the presentation of this information in a readable and interpretable manner. And then we are, looking at this human body that is treated as a black box, the unknown system, within which there are certain kinds of signals and systems that are found inside, interacting with one another. So if you look at this, you can see the various components of this man instrumentation system. Primarily, we talk about the subject, the human being on which the measurements are to be carried out. And then you have the stimulus. Stimulus in many ways can be an external triggering that is required to initiate a measurement process. The stimulus can be a visual, auditory, or a tactile, or even a direct electrical stimulation of some part of the nervous system. So this forms the major component. Then you have the transducer, basically a device which is capable of converting the measured signal into a form of energy, interpretable, and recording for further study and analysis. Then you have the various signal conditioning equipments. Most signals that are received from the human body are very weak signals. Therefore, these signals have to be amplified. So you need a good amplification system, certain modifications so that they can be interpreted properly. Then you have the various display set of equipments for the data to be more meaningful. The electrical output of the earlier system has to be converted into a form which can be perceived by the human senses. So this requirement makes the display as one of the vital component, we can say. And then you need to have the recording, the data processing, the transmission. All this come under this recording setup. This is basically done for further analysis of the whatever the variables that we are measuring. So the data needs to be recorded, transmitted over various locations. So this is also very vital part of the composition of this system. Then you have the control devices, wherein this forms the final component of this man instrumentation system. So this gives the operator the flexibility of the autonomic control of the stimulus. So this is achieved by incorporating a kind of a feedback mechanism or a feedback loop in the system. So now let us move forward. We will have a quick summary of how the medical devices are classified. So we have something broadly categorized into diagnostic equipments, therapeutic equipments, ambulatory care products, and home healthcare equipments. So when we talk about the diagnostic equipments, we are talking about the various methods, procedures, and the tests that are performed to diagnose a disease or a function or a condition. And then the set of equipments that are used to treat this condition or used for therapeutic applications that come under the therapeutic equipments category. Then you have the ambulatory care products, which is used to administer the health services to the subject or the patients or the individuals who actually do not require hospitalization or institutionalization. Then the fourth category is the home healthcare, as the name suggests, which can be used by patients at home, in home for it can be even for a simple blood pressure recording, or it can be even for a more complicated or critical ill conditions. So that is a broad category of how the medical devices are categorized. So we definitely come across various medical devices in our day-to-day life, especially if we are connected with the hospitals or if we are connected with this biomedical domain. We would have already heard about a lot of these names. So we have a range of medical devices, especially the ECG machines, the scanners, the dermoscopes, something related to the eye. You have the slit lamp, fundus camera, or the ophthalmoscope. You have the microscopes, endoscopes, otoscopes, vital sign monitors, electronic BP monitors. You have glucometers, electronic stethoscopes, ASPO monitors, ultrasound, CT, MRI, and computed radiology or digital radiography. So you name it. All these are all just to give you a glimpse of some of the major medical devices that we commonly come across. So by looking into this slide, we need to understand how the medical devices or the data are categorized. So you have so many types of devices which are available in the market, but then how are the actual classification done? So primarily, when you look at the classification, medical devices, especially from the medical data perspective, it has three major classifications. One would be the set of equipments which gives waveforms as the output. And the second category is the set of equipments which gives images as the output. And then the third category would be the set of equipments which gives values as the output. So when we talk about waveforms, we know that all the physiological signals, especially the ECG or EEG, EMG, pulse oximetry, all this kind of, we are more used to looking at the waveforms. Of course, the values are also important. Some of these machines also gives values simultaneously along with the waveforms, but primarily the waveform is the most important key feature here. And then when we come to the second category of medical data, we are talking about the images. All the imaging modalities can be brought under this. So the X-ray, CT, MRI, ultrasound, you name all the ophthalmic or pathological slides, skin lesions, all the dermoscope, otoscope. So it's primarily the image that is captured and then which is used for analysis. And then the third set of output, we can talk about all the values. So when we talk about the values, here, for example, we can talk about glucometer. When we talk about glucometer, we are talking about the glucose level, blood glucose level, blood pressure, the systolic and the blood diastolic values. So weight, even a weighing scale for that matter. So these are all some of the major categorization, we can call it. Then, of course, we need to understand the output protocols, especially. Primarily more required, especially from the imaging devices are concerned. So some of the standard outputs that we all know, especially the type of outputs, JPEG or TIF, PNG, AVI, we have so many type of output parameters that are available as standards. So the output protocols from the medical devices, especially that deliver the waveforms and values, they differ from company to company. So hence we need to build an interface for each of these devices, because a company A may come out with a different output protocol. Company B may come out with different output protocol. Whereas, when we talk about the imaging, it is more or less kind of standardized. But whereas these kind of devices which come out with values or waveforms, of course there are different protocols, but then it is not standardized. You have various protocols. For example, when we talk about the device classification, we can see how all these medical equipments have evolved over a period of time. Earlier, the conventional equipments, when we talk about the standalone equipments, and it never had any interfacing capability. But today, present scenario, we are talking about medical equipments with interface capability, which is a major change. And when we talk about the device categories, it used to be dedicated, and today we are talking about network. So, which is a most important key aspect when we talk about especially the telemedicine and things like that. And when we talk about the medical data, it was analog all the way, and then now we are talking about digitizing the medical data. Standards, there were no standards earlier. Now we have so many standards that are coming to the picture, DICOM standards, HL7, and so on. And when it comes to data viewing, it was fixed to one location, and today we are talking about accessing all this data sitting across the globe, sitting in any location, you are able to have the access to this medical data, which is a significant change. So let us quickly go through some of these medical equipments in terms of the modalities and the applications. This is going to give you an idea of how the products are integrated with respect to the output. So broadly, you can run down. For example, you can say this cardiology as a modality. We're talking about some of the basic equipments like ECG or event recorders or Holter monitoring or echocardiograph, and then you look at the interfacing. So you have some of the equipments with RS-232 or USB. Some of the recorders will have infrared or USB or TCP/IP video output. So you have range of interfaces available. So these options are limited, but it depends on how you choose as a clinician or as a patient. If you are trying to evaluate as to how these equipments work, or as an investigator, we are trying to understand what kind of interface modalities are available. This is going to give you a glimpse of all this. So let us look into the radiology as a modality here. So we have the cath lab or X-ray, CT, MRI, or CRDR or CT, ultrasound. So you see all the type of different output protocols, especially for the interfacing point of view. Ophthalmoscope, you have the video output, of course, that is very key here. Then you have the ENT, again a video output. Dermatology, again a video output. We talk about dermoscopes, CCD cameras or digital cameras. So moving forward, we have pathology. So primarily the microscopes are used. Now you have the USB interface available for all the microscopes. Then you're talking about all the endoscopes which are used in performing surgeries. Video output is the key here. So video interface, critical care or emergency, we have even today the RS-232 is being commonly used, especially in the multi-parameter monitors. USB is available as far as some of the nursing stations are concerned, but again it is RS-232 or TCP/IP. Spirometers, even today we have USB or RS-232. EEG, primarily USB or TCP/IP, and then so on. So you have a brief idea as to what kind of integration happens to a product when it comes to choosing the modalities or the applications, and then what kind of interfaces. So in brief, so this is how the medical device interface can be mapped. You have the vital sign devices, so the imaging devices, or the handheld devices. So the range of interfaces, RS-232, USB, Ethernet, video output, Bluetooth, or mic, whatever it may be. And then you have the data coming through this interfaces. So this is, in a nutshell, a summary of how the medical device integration happens. Then we talk about the applications. For example, this is basically we are talking about how it is used in telemedicine platform. So you have various medical devices that are kind of integrated. It can be ECG or electronic stethoscope, echocardiogram, scanners, or the images from various scopes, ophthalmoscope, microscopes on one end. And then that is connected from the remote end to the specialist end through various modes of communication, or wireless communication, satellite communication. It can be any kind of robust means of being able to transmit this data. And then from the specialist end, the specialists or the doctors can monitor all these outputs. So for example, you can see the waveforms as far as the telecardiography is concerned, or telepathology, teleradiology, telesurgery. So this is going to be the order of the day, especially in the coming decades. So we have already seen this telemedicine platform being, penetrated into nook and corner across the globe now, especially in India. It is slowly picking up. So we are going to see a lot of medical devices getting integrated into this telemedicine platform, and this is going to be the big change. I would put it that way in the next coming years. So primarily, one has to look at all these categories in this medical field. So we all know all this. So in spite of that, I've just added this just to have a fair idea of various categories when we talk about the medical field, starting with cardiology, radiology, and it goes on and on. So every field is so important, so vital, and every aspect of the medical devices come into the picture depending on the categories. And then this is basically the workflow. So when we talk about irrespective of any medical device categories, so we need to identify the medical devices with respect to the category, and then we equip and integrate this medical devices to the respective platform, and then the interfacing or the networking comes into the picture. Then we talk about the data transmission. Then you have the patient information and the data storage happening, and from there it goes to the specialist. So this is kind of completing this loop, how the workflow of this medical device and medical data as far as the classification, integration, and transmission. So we have worked with one principal investigator of VIT, where we developed a Pro2, which is basically used for diabetic, I would say, it's a diabetic healthcare unit. So we collaborated with VIT University, and we were able to, come out with a product out of a joint collaboration. So coming back to the the discussions, primarily we have to, after going through all the different types of medical devices, various categories, how it is going to be used. So now we need to talk about from the design aspects of the medical equipments. So the most important aspect here is from its understanding from its mechanical size and shape. So when we talk about designing a product, we need to look at it from the mechanical shape and size. So how big or how small a product has to be, that has to be kept in mind. What is going to be the form factor, how is the shape, what is the weight, what is the look and feel of this product. So all this comes into picture. For example, we're talking about a defibrillator. A defibrillator is a bulky product as far as handling that is concerned. You have different types of ventilators available, and especially nowadays you have something called as AEDs, automated external defibrillators, which even a layman can use. Whereas the normal defibrillators has to be used by paramedic or specialized personnel because it becomes a little complicated, especially when you're trying to, use this device on a patient who is under fibrillation condition. So the shape and size, what I mean here is the mechanical shape and size. So the device has to be adequately big. Of course, the electronics is inside. You need to store energy. You need to, discharge that energy. You need to house all the discharge paddles, and then it has to have a big display which will be able to give you the ECG data and also all the various settings that the person who is handling this equipment needs to understand. It should be easy to operate. So one has to consider all these things, and it should also be carryable. It's not that it's so bulky that we cannot carry it. So the ideal aspect of all this, especially when it comes to design. So that is where a product becomes successful or a failure. So that is what is going to determine, especially whether a product which is developed becomes user friendly or not, considering from the mechanical aspects. For example, you have a pacemaker. A pacemaker has to be as small as possible, and you're talking about the form factor here. You're talking about the various electronics which are fitted inside. It has a battery inside which has to work for a long time, and then the biocompatibility, how you're going to place it inside the body, and then a lot of intricacies can be looked at when you talk about the shape and size. So it becomes even more important as a design engineers to keep always in mind before you kind of go into the manufacturing process. So that is why we know the importance of understanding the human body functions are concerned, especially when we talk about the anatomy and physiology. Because without that, it becomes impossible for any design engineer to appreciate, especially when it comes to medical devices. If it is any other product, the kind of the importance can be slightly downgraded. But then when we talk about connecting the medical devices with humans, it becomes even more important. A simple blood pressure monitor, which we all have used over so many years, it's so handy, it's so portable, it's so user friendly, and then it becomes easy for anybody to connect to themselves and then quickly have a recording of the blood pressure. So this is one aspect of the design aspects. So the second important design aspect when we talk about the medical devices is to understand from the electrical specifications point of view. So when we talk about the electrical specifications, for example, we can look at this ECG machine. So some of the features and specifications are highlighted. And when we talk about the electrical specification, this is what is going to determine what your product is going to be. So what kind of, the specifications are chosen? The specifications come second. First is the feature. So when we talk about the features, what are the things that you want your device to come out with? For example, a ECG machine should have a good display. It should have a printer built in. Ideally, it should work with a battery, and then it should have all the alarm settings and other control settings available. It should be able to provide all the important or relevant information that are required by the physicians, by the clinicians. So these are some of the features that we normally list out. Once the features are listed out, then it becomes easy as an engineer for us to look into the specifications. For example, we are talking about ECG here. How many leads basically are going to be used? For example, 5 lead or 10 lead, 12 lead ECG. What kind of lead selections can be, incorporated here? So when you talk about all the leads to be acquired, then we need to have all the lead selection made available. Whether it is simultaneous recording, whether it is going to be chosen, depending on the selection, all these have to be kept in mind. And the most important part here, when we talk about the actual, from the electronics point of view, you need to have a good amplifier here, a good instrumentation amplifier, a good, a device that can pick up, which can filter the noise, which can, adequately cover the entire range with good accuracy and a good resolution. So all this gain and things like that. This is even more important. And most importantly, the power supply. Of course, you use it with a battery, but then you have to periodically keep charging this battery so that, you're able to use this ECG machine for 3 to 4 hours of continuous operation or whatever it is. So you have to ensure all the electrical safety aspects. All these things come into the picture when we talk about the electrical specifications. So here, this is one important design aspect that one has to keep in mind. Then the most other important design aspect is looking into the input, output, and display point of view. For example, this is an example of a stress test setup where the ECG leads are connected, and then the patient is made to work on a treadmill, and then you need to have a good big display which can be monitored, and then on the other side, whoever is handling the device should be able to easily get access to this data. And then from the patient's point of view, we need to have a kind of interfacing in such a way that it doesn't disturb the patient's end, especially while performing certain tasks that is assigned to the subject. And then on the other end, at the end of the day, it should be able to suffice the requirement, what it is designed for. For example, a treadmill with a monitoring system. And then the other most important aspect here is by looking at the medical devices design point of view, by looking from the circuit diagrams. So as an engineer, we have to talk more of this aspects than talking as a layman here. So one has to understand from the design aspects what kind of the circuits go into the development of this kind of machines. For example, a ECG machine here, it uses an instrumentation amplifier, and then what kind of signal conditioning is used, what is the gain, what is the filtering, what kind of filters are being used, whether it is first order, second order, Butterworth, Chebyshev, or whatever may be the filters. And then you have the right leg drive that is coming through to reject all the noise factors. And then you are able to pick up the basic ECG information, which can be, taken forward for further processing. You can connect it to any processor or a DAC. But then looking from the circuit diagrams is going to give you a lot of information as an electronics engineer. So when you look at it, it becomes even more important. This gives more relevance as to how to choose the instrumentation amplifier, how to choose the components, various semiconductor devices that are available in the market. Because today you have access to all these electronic devices, and then we can just go and browse for all this information that is available, and we don't have to struggle trying to design or develop the amplifier. All the intelligence is already provided in the chip. We just take a chip, provide the necessary inputs and the outputs, and you're able to quickly acquire this ECG from the subject. So, for example, the internal circuit diagram of this is one I picked up from the internet. This is one circuit diagram of the ECG machine that is available. So we can have a look at it, how the construction of the circuit is. So we are talking about acquiring from the leads, and then you're trying to amplify it, and then you're able to get the ECG data, and then you have the various interfaces available. A simple circuit diagram of a blood pressure monitor, BP monitor. So you have the power supply section, and then the construction of this analog circuit, which is used to run this motor valve, control the valves, and then you're able to integrate it, and you get the AC waveforms. So once we start analyzing or interpreting the circuit diagrams, our kind of ideas are kind of really refreshed, and then we are able to connect exactly as to how we are moving forward as far as the design aspects are concerned. All this comes into the picture, especially when we talk about designing or developing certain circuits. It need not be a biomedical application, it can be any other instrumentation or electronics application. And then we can look at the design aspects of the biomedical equipments in terms of its building blocks. We call it block diagrams. Especially when you look at this kind of block diagram, this is going to give you a lot of information. So we are talking about the ECG amplifier, what kind of the amplifiers, what is the gain of the amplifier, what kind of data acquisition is used, how are this information which are being acquired, how can we control that, what kind of interface is available, what kind of communication protocol has to be enabled. All this we can sum it up by putting it in a block diagram, or by looking at a block diagram as a reference, which is going to give you a lot of information. So as a designers, one need to really give more attention to all these aspects: specifications, block diagrams, features. So these are all the most important basics when we talk about development. Another block diagram. So for example, this is again a BP meter. So you can easily understand by looking into this block diagram how the electronic blocks are interlinked, interconnected, and how the communication is being moved from one stage to another stage. So a lot of information can be acquired just by looking at this block diagrams. So here you can also see the microcontrollers being used, the ADC, all the power management is also incorporated here. This is another block diagram of a defibrillator. So you can see how what are the various building blocks of this defibrillator. You have the instrumentation amplifier on the other end, the amplifiers. Then you have on the other side, operator or the patient feedback. And then you have the data that is coming out. And then you have a big power supply section on one side. And then what is the battery backup? What is the battery pack that is used here? This is a block diagram of a pacemaker. So once again, pacemaker can be of different types. You can have a fixed rate pacemaker or a demand type pacemaker. Can be implantable type, it can be external type, can be programmable type. So there are so many different types of pacemakers. But then the most important part of the pacemaker is the oscillator. One has to, understand the pacing pulses that has to be generated, and then how it is controlled, how that is actually being used in terms of logic to sense or to pace. So what are the various feedback mechanism that goes into this? So a lot of intelligence has to be enabled as far as the functioning of the pacemaker is concerned. So one has to, understand all the basics of the functioning by looking at this block diagram. And then another most important aspect of looking into the design aspects would be the biomedical sensors or electrodes or the transducers. So we all know about the electrodes. Basically, we need to convert this ionic potential into the electrical voltages, which can be monitored, measured, or displayed in a meaningful way to the physician for diagnosis or treatment of any conditions. So some of the basic electrodes that we come across: surface electrodes, microelectrodes, needle electrodes. We have different type of electrodes that are being used. So we can see the plate electrodes. So not only by knowing about the surface electrodes, but also we need to understand from the application perspective. So what kind of electrodes are used for picking up a different set of bioelectric signals? We have disposable electrodes, suction cup electrodes, again the limb electrodes, the clip type, disc electrodes. So all these basically are surface electrodes. So the suction cup is primarily used, as you are aware, along with the limb electrodes and disposable electrodes for picking up electrocardiogram. Then you have the disc electrodes or the cup electrodes, which are used to pick up electroencephalogram. Microelectrodes here. So you see the tip profiling here. It's so narrow or it's so fine that by ensuring that by using this microelectrodes we don't damage the cell, but it should be able to penetrate the cell without damaging. So that way we ensure that the information from the cell can be picked up. Needle electrodes, again used for EMG recording. In some cases it is used for EEG recording. Biopotential electrodes. So some of the other, we can quickly have a look at some of the sensors here. Talking about commonly used sensors. Like for example, this is a moving coil microphone. Works on this electromagnetic induction principle. We use the moving coil diaphragm especially for picking up phonocardiogram activity. So PCG sometimes we can use either an electric microphone or a moving coil diaphragm type, which is quite good when it comes to picking up the chest sounds. Different types of pressure sensors. We have range of pressure sensors. We have the humidity sensors. Pulse oximeter sensor. This is very common. I'm sure everyone would have, come across when it comes to, handling pulse oximeters. It's so simple, but then very effective. Nowadays, you have this small portable devices that have come into the market, where you just have to, plug into your finger, and then on the other end, you have the display which gives you the oxygen saturation levels along with the pulse rate and things like that. But then when it comes to the construction of this probe, it's very complicated. Though it may look simple, there are so many sub-assemblies inside. So, and then you will have to, place the light sensors appropriately. So choosing the right sensor, choosing the right part becomes very, very critical here. Because, this is so commonly used, the wear and tear factor has to be kept in mind. Ultrasonic transducer, once again, you can see the electronics. So normally we don't see the electronics inside because it is encapsulated. But then when you open it up, you have the electronics inside, how it is energized, what is the power supply that goes into it, and then on the other side you have the probe that is used to pick up the information from the body. Construction of this ultrasonic transducer, you can see another commonly used sensor, the load cell. So when you talk about understanding this and the building blocks, again, coming back to this, so by understanding the block diagram, it becomes very easy for us to understand how equipment functions. For example, you have this ECG machine. You break it open into its building blocks. We can categorize them into different blocks altogether. So you have the power supply. The power supply is battery, of course. Then you have the electrodes. Electrodes are nothing but the leads that get connected to the subject. Then you have the instrumentation amplifier, which is nothing but the ECG amplifier. You have the QRS filter, QRS detector. So this is basically the most important parameter when it comes to determining the ECG. The most important, the prominent part of the ECG is your QRS. The QRS complex has to be, detected. And then you talk about the refractory period. To avoid any false detection of QRS, and then you try to synchronize this. So when we talk about the false detection to be avoided, we kind of can use a non-re-triggerable mono-stable multivibrators there, and then we kind of use a universal sync pulse, a 100 millisecond sync pulse, which normally all the ECG equipment manufacturers use, and then you connect the frequency into voltage, and then you are able to, set the limits for high alarm or a low alarm, like a bradycardia condition or a tachycardia condition, and then you are able to display this heart rate, and then you can also have a audio output, a buzzer, so which is going to beep the moment the heart rate goes above normal or below normal. So you can set the rates for tachycardia or bradycardia condition. So this is how we can look at building the medical devices in terms of building blocks. So this way it becomes easy for us to interpret and also know what is the electronics inside and where we have to focus. For example, I've taken this example of a BP, blood pressure. You have the pressure sensor in the cuff, you have the pressure amplifier, a DVM, pressure pulse amplifier, which is going to, there are different algorithms that can be used. You have certain algorithms which can be used. Normally it is deflating algorithms. Sometimes in some exceptional cases, there is also algorithms for inflation stage, where when the pressure is inflating, it starts analyzing. In some cases, the commonly used, they use the deflating algorithm. So once the pressure is inflated to adequate level, well above the arterial pressure, then it stops and then starts slowly to deflate, and then the sensor starts picking up the turbulence, is able to pick up the information, the systolic and the diastolic. And then you also have the audio information if required, you can have it.